much better. You're all lit up.
Even lighting anyways.
Like a Christmas tree.
And that is the magic signal that says, Happy Friday, Scott.
Well, happy Friday, Dave. How are you?
You know, woke up alive, stayed up all night every week this week, working on clusters and so ready to do this and then take a nap. And you?
That sounds great. I stayed up all night working on Security Plus because, that's what I keep doing.
Because when you're done with it, you're never really done with it, are you?
No, we're not. So, hey, everyone. Welcome to the Friday Dave Rush Ask Me Anything plus me, Scott.
Dramas.
Hey,
and Scott. Drama and Scott.
We're here today and every Friday to be there to answer your questions on CompTIA certifications, on any kind of IT stuff. And we're here because a lot of us are still in lockdown because of the COVID crisis, and we can't go to class to study. We can't go to class to teach, which is what is driving Dave and I crazy. And so we're reaching out and hopefully having some good impact on your studying and certainly some good impact on our need to talk. So there we go. My colleague here is Dave Rush. Dave?
Greetings and salutations. I am Dave Rush, senior instructor at Total Seminars. Do everything else when I'm not instructing. In fact, per that, Scott's let me work on a quiet project on the side, and he had McGraw-Hill send me this shiny new piece of research.
Excellent.
Wow, everything in my system just flashed. So this is helping out my research as we develop a potential, video class, stand-up class, passport book, whatever we come up with. I'm excited. I just got that much more good stuff to read.
Absolutely.
Excuse me.
I'm Scott Jernigan, the other half of the Dave plus Scott duo. I'm editor-in-chief for Total Seminars, and a longtime contributor with Mike Meyers. I've written and edited dozens and dozens of books with Mike over the years and taught classes all over the country. And, all around nice guy. So there you go. I'm mainly here as Dave's sidekick. He's the pie guy. I'm the sidekick. Life is good. But we've got lots of institutional knowledge between us, and we can definitely ask questions all day long. We can answer them too sometimes. So there you go.
Very nice. I should tell you that a little bit before I joined Total Seminars, it was over 10 years ago now, I started working on a book, and I'm happy to say that I completed it this week.
Wow, really?
Next week I'm going to start reading another one. So that joke never gets old. I love that one.
It doesn't get old. That's great. I love it. And we are too, Telewit. In fact, Dave, what are we going to do today aside from the regular questions?
Oh, I have no idea.
Oh, okay. Never mind.
Make it up as we go along. But of course, the plan has been, and we announced last week the intent, and it's working out. We're going to start a two-part series on clustered computing. Of course, this AMA, this drama, is focused on using Raspberry Pis as tools to learn all kinds of technology, the Pi itself, CompTIA projects, and computing concepts. So we looked at this a very long time ago. There has to come a time we decided that we're going to do a popular project that's usually in the world of Raspberry Pi, a learning project. They're tiny little computers. They're nice for what they do, but they're really not designed to do high power computing. HPC, there's a specific phrase for that. But conceptually, they work the same way as doing multi-parallel computing with supercomputers. So what we're going to do is a two-part series. Today is the boring part. So we're going to talk about what clustered computing is and massive parallel computing and messaging, and just lay down foundations and concepts. And at the end of that presentation, I have a 9-step process that I'm just going to read off to you that says, here's how to do Raspberry Pi clustering. And then next week, we will employ those 9 steps and create a cluster. And I guess I'll get this out of the way now. We can't do it in real time. I cannot have you do this along with me because there are steps that take 2 hours. And there are a multitude of steps that will take plus or minus 1 hour, depends on how many processing nodes you have.
So we're going to have some time lapse moments.
No, we're not. It's all going to be done in advance, and I'm just going to say, here's what you do, and we're going to give it kind of the Julia Childs thing. We'll have a raw roast out in front, and so what you do is you'll tie it up like this, and when it's done, we'll put one in a dead oven, and then pull out one from the live oven. It looks like this.
I like it. Okay.
Well, that was the world's worst Julia Childs impression.
I thought it was brilliant, Dave. Brilliant.
Sorry.
You've missed your calling as a impersonator.
Yeah. I suppose I can do a few impressions, but Julia's just not among them. Hey, well, we get together 3 days a week here. Mike does a pair of AMAs on Monday and Wednesday at 2 o'clock Central. We get together with everybody here on Friday at 2 o'clock Central for 2 hours to talk about all things CompTIA, computer technology, Raspberry Pis, do projects, and recognize we don't have to do all these Linux-oriented projects on Raspberry Pis. Some of them will work on, most of them will work on any Linux box you can create or get your hands on, and a lot of them, as far as these software packages go, will even run just fine on a Windows machine. So don't feel like you have to run out and buy a Raspberry Pi to do this stuff with us. You can follow along, you can read along, and I usually, when there's another, sorry about that, venue that you can try this on, then I'll provide that for you. So please try it all.
Absolutely.
And otherwise, all topics fair game except religion, politics, and I swear I do not ever want to hear the word COVID again. I know. It's why we're here. I'm tired of being here for that. And you know what? Mike lets us do this. And many thanks to Mike for letting us take a couple of times of hours off during our regular Total Seminars work week to get together with you and share information and talk and listen and learn. I don't know what his plans are if and when we get back in the office, but one way or the other, I'm going to keep doing this. If I have to do it late night with 3 people watching and everybody else can watch it on the archive, I love this stuff.
Yeah. You do it really, really late night, then all of our European friends will be there having morning coffee or morning tea and enjoying you. So,
well, let's see what's...
The puns have already started, so go ahead. Yeah. Tell us what the shirt is behind you and the significance of that shirt.
There's nothing significant. It's just a concert shirt of a concert I went to. I've had this shirt up in the past. I'm kind of run through my retinue of shirts. I'm recycling now. I've been shopping for some shirts from concerts that I've been to, or artists whose concerts I've been to, but didn't buy the shirt at that time. Disappointing. So that was a Pat Benatar and Neil Giraldo. Wasn't a Q&A kind of thing, but they just took the stage and talked about their history and their songwriting, and did a few songs and at least some cuts of some of the songs, and just kind of an enjoyable, almost in the round type experience. And I coughed up big bucks for that one. I bought the VIP package. It came with the shirts and with posters and with a backstage visit, and just fun.
Oh, very fun. Pat Benatar was one of the first concerts I ever went to.
Really?
Yeah. And talk about a powerhouse singer. Oh. Those of you who are a little younger won't necessarily know who she is. She was kind of the Christina Aguilera of her generation, with a voice that do 5 or 6 octaves, just a stupendous stage presence and repertoire. So anyway,
that was one of the really amazing things. I'll do that with you. At some point, she was going to sing one of her powerhouse songs, and she'd had the mic in her hand and was communicating like this. It didn't say peach tea, but you get the idea. And then Neil starts playing a loop, and he's on guitar, and she took her microphone. I can't show you this, but she put it down by her thigh and began to sing because she didn't want to blast away and clip on the mic. And I don't think she needed it. We all would have heard her without it, but it picked up a little bit of it for effects. And man, I mean, she was a trained operatic singer.
Right. Before she went rock and roll. Because, once you go rock and roll.
Darn right. Hey, let me put this up and maybe you'll talk about it, Scott.
If you need to contact us, if you have questions and they go a little beyond where you want to, you feel comfortable with right here in the chat asking questions, you can always just send an email to us. Dave's email is daver@totalsim.com. Mine is scottj@totalsim.com. You can also email Mike. Guess what his is? Michael M@totalsim.com. I know, pretty creative folks here at Total Seminars. Yeah. You could call us. Nobody's in the office right now, but it'll get to our answering service and eventually get to us. And our number's right there on the screen. You can always follow Dave or me on Steam. We're gamers both. Dave is drushtx, and I'm Scarhart, no E. Feel free to friend us, and we're on. Say hi and jump in. Let's do some multiplayer games. Bang bang.
While you're at it, don't forget, if you're here live or if you're watching this on archive later, please like and subscribe. It helps your fellow students who are looking for information about the topics that we cover to find these things in our YouTube archive.
Absolutely.
They're all indexed, and so they can search for them on keywords. You can do the same thing.
Yep.
And hopefully, with all of the cross communication that we had on these, I've got this right. Just because you've been kind enough to join us this week, we got specials for you at the Total Sim store. And we don't advertise this anyplace else except on our AMAs, Mike's Monday, Wednesdays, and Scott and Mai's drama on Friday. This week, 20% off A+, Net Plus, and Sec Plus Passport ebooks. There's other ebooks out there. They aren't the beneficiary of this largesse, but for the Passport ebooks for those 3 titles, head on over to the Total Sim, load up on lots of loot, throw in this code Groundhog 2021 at checkout. And that's good through this Sunday, January 7th. I don't know what time. If you're a teacher, contact Kathy Y at totalsim.com. It's Kathy Yale. You're teaching a live, accurate class in the school system right now. Can be remotely, can be face-to-face, in person. She's got stuff for you. So don't try to fake her. You're not going to get any freebies out of her if you're not a teacher that she can confirm with. But if you're a teacher, if you hear word of this after this live one, please contact Kathy Yale. She wants to help you out. All right, we'll do this guy later.
All right.
Yeah,
that's like all the official business wrapped into one 10-minute segment. That's pretty awesome.
Well, let's see what's happening in the world today in live chat. Tullowit punches in at 1:22. I can't stick to my things, so I'm not going to look at things that happened before then.
Might as well.
Oh, I do.
I think we went pretty pirate theme before we started this morning or this afternoon.
Yeah. I was reading something naval and saw cast off all lines, and I went down the rabbit hole trying to find out all of the orders of commands that the officer of the deck gives when you're making preparations to get underway. And I couldn't find anything. I couldn't find all the specific in-order commands. There's lots of other in-order commands for naval jargon for executing a particular task, but I just couldn't find the one for getting underway. So I grabbed some lines that I've heard in movies.
Well, there we go.
You who were in the Navy,
probably
feel free to fix me.
Accurate enough.
Yeah. That was, wow, I don't know how to pronounce that. Cephadius or Cephodius. I apologize for mangling your name on at least one of those efforts, but
right.
Yep.
Welcome.
Swat on the deck because no one else will.
Awesome. So if you, we will be kind of going through the comments and questions and stuff via the timestamp, and we'll mention it. If you haven't flipped on the timestamp, you can to be able to follow along where we're at. Click the little vertical ellipses. That's the 3 dots, one on top of the other, in the top right. and you should be able to turn the timestamp on. The second thing to turn on is to flip from top chat to live chat. It's top chat filters out a bunch of stuff, including anytime we throw numbers at you, they'll just disappear. So you'll be like, what are you talking about? And it's like, it's right there on your screen. And like, if you haven't flipped to live chat from top chat, you won't see that stuff. So I advise you to flip to live chat.
You know, it's really funny. Mike has done 120 or so of these. This is our 25th. And only in the last week or so have we actually gotten around to suggesting that to everybody. Mostly everything was working for everybody and we didn't have to push that. But lately, in the last 2-3 weeks, people have not been able to see some of the things that we're talking about. So
yeah, Mike has been on a tear. In case you want to go back, all the archives of all of the AMAs are right there on YouTube in the Total Seminars channel. Mike has been on a tear the last 4 sessions doing IPv4 subnetting. So if you're setting for Network Plus and really need to get some subnetting on, because don't we all? You can check out those videos. And it was during those subnetting when people were putting in all the just straight up binary, YouTube was like, that must be spam. Yeah. And just blocked it all out of the top chat. So if you hadn't flipped the live chat, you wouldn't have seen it. So anyway, all right. So we're at 2:01. Patricia, thank you for, I can't say that. Thank you for sharing the fact that we're doing a lovely pie. Thank you very much for sharing with other people that we're doing pies on Fridays.
Yeah, appreciate that.
And very much appreciated. And hopefully we will see some of your friends from MeWe Raspberry Pi. So there we go.
And I super scrolled. I love when that happens.
Uh-oh. So Kevin Lopez is here. Tellowood, of course, is here.
Yeah, we've got a lot going on.
Tellowood's fired up about pie clusters. Absolutely. Andre, of course, wanting Linux Plus because don't we all? Yes, absolutely.
Hey, Patricia, either here or in Discord later, and we'll give everybody the Discord link in a little bit. Tell us about that MeWe group. I'm curious. Unless Scott already knows what MeWe is.
I don't.
Okay, good.
No clue. Tell us everything, Patricia. We need answers.
Linux Plus. Nice. That's on my wish list. Yeah, I mean, there's no commitment there. It's just me working in my own time, making an outline of something that might turn into something, or not. But
once I get finished with Security Plus, I'll be doing the same thing. And then once we have a kind of a good outline, whether it's a stand-up comedy routine or whether it's an actual video series, we'll float that to our money boss, Dudley, and hopefully he'll say, that sounds like a great idea, guys. Make it happen.
It is a great idea. There's no question about it. There is such demand for it. It's just a question of, can you do it in 10 man hours and I do it in 8 man hours? So get the 18 in there and make ROI. Yep. Good pun. Thought it was just promises in the dark for our class. So that's one of the best puns you've made. Now stop it.
But Dave, you can continue in the heat of the night.
Oh, Jiminy Christmas.
That was another Tellowood. It wasn't me. I'm stealing.
Yeah. I'm looking at it. And racing past it. Repeating T-shirts is kind of a heartbreaker. Ugh.
Yeah. I know.
All right. I'm going to stop reading Tellowood. It's out loud. There's a good question from Choco Taco. This is 210 for everybody who's not playing on Discord. Tellowood's background is a chef, and he was looking for and discussing sea cucumbers. I don't know why. Even as a child, I whined about this. They're not called sea cumbers, but he was looking for recipes for sea cucumbers.
Sea cumbers, really?
You wouldn't call them sea cumbers?
No, I would now. That's great.
It just, I think since I heard of them at 6 years old, that seemed to be the natural name.
I like it. And then we're talking, we obviously went retro with some MTV memories from some people. And back when MTV actually played videos, that was a cool time. It was a very interesting time.
You got to be our age to know that one.
Yep.
That's what I like about Sirius XM. Every one of the old VJs has at least one show on Sirius XM in the classic rock categories.
Huh. Nice.
So very enjoyable to listen to those folks. One of them sounds like she has smoked 2 packs every day since that day.
Oh boy.
But the rest of them right in there.
Oh well.
A good program not long ago that documented its beginnings. Okay, we are definitely going down the MTV rabbit hole. I actually know the woman who was married to the first MTV VJ. Well, the woman's cousin's friend's roommate's brother's uncle, but yeah. So cool.
I believe Chaco.
I do too.
So there you go. I have faith in you, man.
Lives here in Baum. Nice.
I assume that's Alabama.
I could have gone 2 ways on that. Chaco is, I think Chaco's around Huntsville, if I remember right. We've talked some of the NASA stuff in Huntsville with him. I'm pretty sure. Yeah, Mark Goodman was one of the names I was going to mention. His voice still sounds good.
Yeah, and Kennedy, of course, has been active.
So we're not doing Trek Tullowit. Patricia Grace is putting times in at 2:15, 3:14, and 3:15. Is that when you want me to get around to doing something?
I think
Because I'm going to do something at 3:14 and 3:15, though I don't know what it is yet.
I think that's her time zone posting, so that people would sync up with what she was posting.
Got it.
That's my theory. I'm sticking to it. Yep, there we go. And that's what she said.
Okay.
So I'm watching the live stream over here on my other monitor, and then kind of doing the same thing Dave is, sort of tracking time-wise in front of me. So every once in a while I'll crack up because you guys will say something funny, and that's the way it works. So
But leave the comedy to the professionals. Or Scott or I.
Yeah.
Yeah, I was thinking about that. So today, make sure you got pen and paper in hand so you can write down the 9 steps that we're going to do next week.
If you don't have pen and paper, you're wasting your time.
Don't waste my time. Don't waste your time. And if you don't have pen, poke your finger so you can write in blood.
And we're parodying our boss, Mike Meyers, because he got so adamant about people using pen and paper with subnetting, which is how we do it, but it was kind of funny. Anyway, we only make fun of him because we love him.
Absolutely. And because he pays us. Alex, I don't see icons that I didn't post.
Yes,
icons that I didn't post.
Yeah, when she initially posted, there was this weird kind of cloud icon next to her non-smiley smiley face.
Okay.
No clue.
Yeah. Glitch in the matrix.
Yep.
So yes, I will be on Discord after today. I had to miss Monday, Wednesday because busy life, busy wife, and part of busy wife, she's got a new job. So I got Mr. Mom duties.
Wow, congrats.
I have to have dinner on the table ready to go when she gets back at 5:00 our time. I'm not sure if that's going to happen today or not, but dinner's easy, so I can just shove it in and come back here to Uncle Computer. So
gotcha.
Speaking of then,
such
niceties as Discord.
So we do not have, but our friend Jose Braden has put up the unofficial Total Seminars channel Discord, and nobody at Total Seminars is officially affiliated with it, although we all hang out there. But here is a link today to the unofficial Discord channel. Feel free to join us. We tend to get a little less formal, believe it or not, in Discord, and things that were off the table in our live stream here, our official live stream, are on the table when we hit Discord. So be prepared for that. But it's all fun and games and lots of really good people that are there. I'll post the link again before we're done with our live show today, and join us on Discord. I'll be a little late. I've got a meeting with our publisher, but yeah, all good.
Yeah, it's all fun and games till somebody loses an eye, but we try to make sure that happens early. I was just being goofy with timestamps. Okay. I'm looking at sea cucumber pics and they don't look like food. You started that conversation the other day on Discord, Tullowit. I started thinking about cucumbers, and then I went down this stupid rabbit hole that says edibles in the ocean. They only have 4 looks, and sea cucumbers are unique. If you look at land-based vegetation, there's all kinds of lumpy, bulbous, I don't have a good term for them, but foods, round sometimes, melons, and oblong sea cucumber-ish like zucchinis and cucumbers and squash and things like that. I can't think of anything outside of a sea cucumber in the ocean that looks like land-based vegetation other than, seaweed and kelp and all that good stuff. Just, there's nothing that looks like a seacumber, which is its new official name.
Mess up all of our European friends. They'd be like, seacumber? What does that mean?
They wouldn't eat that stuff. Don't worry about it. I don't appreciate the mischaracterization of MM. Says the woman who calls him an asymmetrist. So,
Although still, that's a great name, an asymmetrist.
Absolutely. Yeah, the first time she came up with it, as soon as he said it, I started looking for a word to do it, and she beat me by an hour into it. So kudos for that.
That was pretty awesome.
Hope the new job is working out well for you, Alice. We got a couple of, Patricia. We got a couple other new people who have started new jobs of late. I don't see Zach here.
No, not yet.
I don't see Step Closer here. They're all got new work.
Which might be what they're doing right now. Well,
yep, and it won't be long, I suspect, before we lose Andre as he goes back to school.
Oh, wow. Okay. It's all good.
Yeah, I saw the Star Wars reference. I let it go. So do you presume, Alex, or do you just know this, that Andre is as multilingual as you? And if you don't know this about Alex, she's got at least 5 solid languages under her belt. David Zintera, our at least recent prize winner on the AMAs. You beat my losing eye line. Sea cucumbers could be monsters in a horror flick. I love horror flicks. Answer your question. She was married to Alan Hunter, who himself hails from Birmingham. Eat it, Dave. What are you talking about, man? I love Birmingham. I'm sorry about the Huntsville reference, but Alabama is just one big city, right? I mean, you get the 3, but when you mash them all together, it's just Mobile, Birmingham, Huntsville, and Tuscaloosa. Oh, Tullowit.
To storm the
27. Not reading or commenting on that one. Shame on you. Well, actually, we're at the bottom of the initial blast. So I got 2 things going on today besides reading and answering questions. Just one brief one. This is apropos of nothing. Let's just call this Dave venting.
Ah, okay. Vent away, my friend. Vent away.
Well, I do this every week, right? We got news of the week and Dave's adventures of the week. And the adventures are usually technical. I don't have a good technical adventure story, but I had an interesting series of events on Saturday. Not this, yeah, it was on Saturday. I had to go over to Mike's house to drop off some stuff and pick up some stuff, followed by a trip to Scott's house. And somewhere in there was another side task. I was going over to Micro Center.
Oh, that's right. Yes.
Historically, for me, a house of worship. Now I'm going to bury a crucifix upside down in their parking lot because they did it to me again. They had an ad. The new Raspberry Pi Pico was out. It was on sale at the advertised price. They don't jack the price. Try again.
Really? Only $2?
Yeah, they're $2.
Wow.
Yeah.
Wow.
Or at least they were on sale that day for $2. So stopped at Mike's and then took the shortest route there, not bothering to check traffic.
Hold on. Let me set the stage a little better, okay? So Micro Center is in Southwest Houston. If you don't really understand how big Houston is? Houston, kind of the metropolitan area, is literally as big as the entire state of Rhode Island, physically and population-wise, okay?
Yep.
Dave lives north of the city, okay? So this, and Micro Center's southwest Houston.
A 60-mile trip.
Serious commitment for a Saturday. So
yeah,
go ahead.
I have to be motivated to go. And my motivation was I was going to pick up a pile of them. Plus I had 2 freebies for 32 gig micro SD cards. They're not great cards, but they're always good to experiment around here. So that makes the trip worthwhile, especially since I've already gone down to Mike's, and that represents about halfway. So, okay, cool. So I launch out of Scott and Mike's neighborhood. They're close together, about 3 miles apart. Though time-wise, it ain't 3 miles. I'll tell you that. I'm sure you know.
No, it's not. It's 20 minutes.
Especially take all the surface streets. So I launched out of there and I didn't check traffic. So I wound up in this horrific traffic jam. And it's quite literally from the time I left my house to the time I got to the front door at Micro Center was about 2 hours. Okay. And then I saw it. I'd seen this before 6 or 8 weeks ago. People milling around out front, not going in, not coming out, and a whole bunch of stapled up signs on the bollards and the walls. And so I foolishly parked and went and looked at the sign. Temporarily closed. We may be open tonight. We don't know. Keep an eye on the website. Well, I gotta hang around a couple hours away when I got nothing else to do down there. So I managed to find a manager who was out there who promised me, oh no, when you do come back, we'll make it good. So I called him yesterday and said, hey, coming down in a little bit, because I also had to go to Mike's yesterday. Oh, they're all gone. We can't make it good. And that expired one that you had that was going to expire on Sunday, and that's why you came down early, headquarters won't let me make that good either. So they are such on my list of never again. I'll get suckered into it again by a good sale, but so
that's
disappointing.
A very sad tale of woe, Dave.
Yeah, it's happened to me before. I went down there once before and they closed without notice on their website. This time they did put the notice on the website, but it was after I was underway and certainly didn't, I don't watch the website while I'm driving. Still open, still open, still open. Maybe I will next time. Maybe I'll write a script.
There you go.
I love that. Runs on an Android phone, Android, and just checks and greps for the word temporarily. That might be a pointless exercise. I think I'll do it.
Sounds awesome.
Yeah.
All right, it's 2:30.
It is.
And we are caught up with questions.
Oh, disappointing. Yeah, really. Make sure you pile up some questions here while I do this other little presentation. Oh God. Tell you what, you are just trolling Zach. I'm glad for you that he's not here. That Cockney at 228.
That's right, Alice. Clustering it is. That is the topic du jour.
Yeah.
See, how about my French there? Mm-hmm.
I like that. I was in a hotel in Paris one time. Wasn't my first time to Paris and been there many, many times, but I have always mispronounced deux as in the number 2.
Yeah, right.
Was never corrected at it. Was never corrected at it, and nobody ever until one of the hotel clerks. I asked for my key, and my room number was 201, and I pronounced it "do." Well, he didn't hit me.
That's something for Paris.
Just that close. And, you speak it and speak it well, or don't bother to try. Because what is your room number in English, please? You are not getting it right. Thanks. You know what I meant. You could have worked with me here, dude. And I'm a Francophile. I love the French and the language, but and I know they're rude if you don't meet their expectations or their bar, but that was the first time anybody really responded to me in a rude way, and I still carry it with me 20 years later.
The hurt, the scar. It will never heal. Duh.
Clustering. I know you're all screaming for it. I'm going to get there. Give me a second here, and I'm going to.
We're ready, Dave.
Powder too soon. I got nothing left but questions and that. So bear with for just a few minutes while I read what Scott said is already read. It's more fun when Zach is here. You're right. But good news, both Elbow and Zach are both here. So there's
Elbow
our
just left,
Elbow
actually.
and Alice.
Elbow just bailed to go back to work.
Oh, of course. Perfect timing. Good to see you, Elbow. We'll see you when you get back. May the 4th. It's not yet. A couple of months before Germans don't care. I'll do Germans and French jokes on Discord. I'm going to let them go. Well, all right. Why not then?
Time to jump in.
Time to jump into it. All right. Notepad, I got to deal with this with notes.
Okay.
How about I put Notepad up here, closest to camera, and I don't need to see
this
that.
stuff while the Dave monologue is going, as he sets his own theater of operations, shall we say, his cockpit of desire, his amazing electronic minions of information. I don't know where.
I was there after the first sentence, but okay. I like the flow of consciousness.
While David's getting ready here.
I guess there is one other thing that we always do. We already covered one, but review of last week, summary of where we're going today. I got kind of prodded into doing that early, but last week we completed a very simple installation of a DNS server. We used Unbound, 4-step process, and the actual process is even less than that. It really comes down to 1 or 2 steps, but we add in there. Make sure you look up the IP address, and if you have to, configure a pie hole to work with it. But what we did was we set up a very simple Unbound DNS server and allowed it to do 2 of its native functions that we don't have to do heavy configuration for. It is by nature, out of the box, a resolving name server. So that went, and it's also a caching name server, which seems to make sense. You can turn either of those functions off, and there are 4 other major functions that it does, plus a huge one, which I think is the most magical. We're going to go and over time revisit this basic installation and add and enable features to that. Sorry for looking outside. I had a nice meeting with my mail carrier today. I have a package that USPS shows delivered 5 days ago, but of course it wasn't. So I had to take him out the paperwork and the tracking number and all the info. And he was just driving around my cul-de-sac again. I thought he found it, he's back, but no, he just healed out. So anyways, the magical thing that we can do with Unbound is there's a built-in DHCP server in the Unbound DNS server. And if you use that instead of the one in your Soho router or the one in your Pi-hole or any other external DHCP server, maybe one from a Windows server, we'll come back to that. If you use the DNS server, so DHCP server in the Unbound DNS server, when it assigns an IP address to a host on your network, it will automatically update the DNS name service entry, the forward lookup zone. So that's really cool and amazing and powerful, and we do the same thing in Windows Server. There's a built-in DHCP server. There's a built-in DNS server. They work collaboratively together to keep everybody updated. But I don't have a Windows server, and if I did, the trial period is only good for 6 months, and I have to start over from scratch. So this could work for years.
So just a matter
of what we did last week and what we're going to do about it later.
A matter of clarification, the Windows Server evaluation copy is now up to 9 months.
Oh, really?
Yeah.
Wonderful.
Plenty of time if you need a copy of Linux. Or sorry, I'm reading the screen. Television, free copy of Linux with every purchase. If you need a copy of Windows Server, head over to Microsoft.com and you can get a nice eval copy for quite a bit of time. So
that's outstanding.
Yeah.
I should redo his whole presentation again now because we've got 9 months. So where we're going today, we start a 2-part series on clustering computers. Today, we're going to look into what clustering is, concepts, foundations, methods, terms, all that good stuff. And we close it up with a 9-step process to create a, here comes the first term, Beowulf cluster.
Woohoo.
Lots of people have
Right.
thrown that term back in my face when I mention clusters, anytime in any place that I mention clusters. So let's get into what that means today. And then part 2, next week, we'll actually create a Beowulf cluster. I'm going to create a 3-node cluster. We're going to talk about why 3 is important. You can do a 2-node cluster. You won't get any benefit out of it, and I'll explain why. But 3 starts to become beneficial. And of course, we'll run a program on it and test it, make sure it's happening. It's kind of cool stuff. And so with that, here we go. Sip, clear my throat. I wrote a lot this week. And I think if I do it all and say it all, it's going to take every bit of time we got left. What do we got? An hour and 20 minutes. So I'm going to cover some of this lightly. We don't need all the details on this. I was talking about Scott about this the other day. There's a lot of reasons to do this. And I want to give you a couple that are outside the norm. We have certainly mentioned things like it's good to know technology, and this is really great technology to know. This may or may not be applicable in certain current or future CompTIA objectives and courses. So one of the things that's going to happen to these notes after this is they're going to go into our research folder for those reasons. So right. You may see that or hear this again at some time in the future in a more formal presentation. It's kind of cool. We're not going to do anything with the Pi today other than, if there's any questions that I have to answer, or I can't think of anything cool that I could demonstrate with it. So this is talk and this is slides. So get some coffee ready. You won't need paper and pencil. If you want to do the 9 steps, I didn't make a slide for that. I'm just going to talk about them. So if we get toward the end, I'll let you know a couple of minutes before I get to the 9 steps. You can get a little piece of paper and pencil and warm up. And I do have at the very end of this presentation a slide that I'm going to put up that shows the primary tutorial that I'm using for next week's project. There's actually a couple of them, but this is the one that's got the most beef that I'm going to use in there. So with that, here we go. It's 1:42. Nope.
Let me throw one little thing out before you.
Please.
So when Dave mentioned that the topic that Dave's about to cover on clustering and stuff might come into play in your near future, have you thought about taking the next Network Plus exam? Not saying anything, but
you are so subtle. I don't get it. What do you mean?
So it's a good topic to learn.
Yeah. Okay. So first question that we've got to answer is, what's a cluster? And there's a lot of different definitions. There's some kind of standardized definitions, but if you go look up 3 different computer term glossaries, you're going to come up with some variants on what a cluster is. So the one that I sort of keyed on that says it's a single logical unit. That's the key phrase. It's made up of multiple computers, and what's probably coming to your mind is a group of computers that work collaboratively on a single project or a program. What I always get in my mind when I see this thing, besides scenes from movies, like what the heck was that movie that came out 2 years ago with Matt Damon stuck on Mars farming?
The Martian?
The Martian. There we go. So somewhere in the middle of that movie, we see our one of our erstwhile, not too much screen time heroes take his laptop and he goes and plugs it in to this corridor full of supercomputers as he works out the marvelous math to rescue our erstwhile Martian. It's not done that way, but I love that imagery. So we've got all of these computers working together for him and sending the output to his laptop that are going to create the mathematical orbital mechanics to pull off the great rescue. And that's the kind of thing that I see. I envision in my mind all the time, meteorology computers, clusters of computers all working on the big worldwide daily, hourly, minutely map. On yeah, second, it's upgraded all the time. And okay, so all kinds of these collaborative projects that work together on a single piece of program, software, whatever, to generate the answer to the great mystery. How much dark matter is in the universe? Where's all the dark matter? How do suns come into existence and stars? And that is absolutely one kind of computer cluster. So all those computers working together collaboratively for one computer that starts the process in motion, feeds the data or provides the data somehow to a massive resource, a big storage device, whatever the case may be. Then they all start doing their thing. And in the end, they say, bing, and they set out a punch card that's got the answer on it. Your ideal companion is a blonde. But there's a couple other kinds of clusters that may be single logical units, but they kind of live in different ways. So there are types of clusters and there are categories within those types. So we got three types of clusters. The first one is called a failover cluster. Failover cluster is kind of what it sounds like. It's either a computer that's part of a cluster that has a backup computer ready to take over if one of the nodes or that node in the active cluster ever fails. And those ones are kind of cool because you have to provide for that backup computer the facility to pick up where the failed unit has left off. It may or may not need to know everything that the failed unit has done up to that time. So we'll see. So let me bring up some graphics of a failover cluster. While I'm doing the other kind of failover cluster is literally a failover cluster. You have a cluster of computers working together on some collaborative project, and something causes that cluster to fail. Maybe it's one node brings them all down. Maybe it's the master node brings them all down. Maybe it's a catastrophe that brings the facility down that's doing these things, and it's mission critical. So we got to bring up another cluster ready to go. So you can have a whole cluster set up ready to pick up where that one left off. And that one's kind of an important difference because it's absolutely critical in that one that it actually runs at the same time as the primary cluster. So if and when the primary cluster goes down, then the backup cluster is ready to kick in and do its magic. We call that a high availability or high resiliency. So this is a typical single node failover system. We've got this whole logical unit here operating, and one of these two machines is the active server in here, or whatever. And what he's doing is processing, he's getting data from here, he's providing information from here, he's getting input from these machines, he's just doing his job. And at the same time, here's a backup system, and they're always just checking on each other. Hey, you alive? Yep, I'm fine. Hey, you alive? Yep, I'm fine. That's called heartbeat. And if ever one of them, primarily this guy is listening to the heartbeat, the guy on the right is listening to the heartbeat of the guy on the left. If he doesn't hear his heartbeat, he says, oh my gosh, the main guy is down, and he's been doing the same thing that this guy's doing. So he picks up right where the dead guy left off. He has access to the same resources. He can communicate with the clients. And notice there is a single virtual IP address here. So what happens is really kind of cool. When this thing takes over for this thing, temporarily, they have different IP addresses. This guy might be 001. This guy might be 002. But when this guy fails, this guy says, oh, got to switch my IP address to 001 so I can look and act and be just like the thing I replaced. So that's a failover cluster. This one's a single node failover. There are entire, clusters that can replace.
Mm-hmm.
The next kind of cluster is one that we've talked about. We just didn't apply the word cluster to it, and that is a load balancing cluster. So load balance is exactly what it sounds like. It's a bunch of computers that are doing the same task. They may not be working collaboratively, but they do exactly the same job. The usual example for this is a bunch of web servers. So let's say that we've got, first of all, a great big storage system. One great big storage system. We'll make it a block level storage system. So it's going to be a SAN, not a NAS. And it talks to its, it communicates with iSCSI, And now I've got these 3 super powerful web servers. And they do searches independently on the data in that great big storage system. So what I want to do is have a load balancer be the front end for that. And load balancers in that kind of system work in 2 ways. One is either round robin or, a priority driven director. So somebody contacts the load balancer. They think they're contacting a web server. And the load balancer, if he's running round robin, says, you get to go talk to web server number 1. And next call, load balancer says, you get to talk to number 2. And next call, number 3. And then it round robins back to 1, 2, and 3. So that's one way to round robin. Mm-hmm. Let's bring up a slide. Okay. Because I have slides like that. Oh, we're going to talk about Beowulf clusters.
Nice.
Thanks. That's really odd. There we go. Yeah. Okay, so no, I had no reason to test all of my graphic slides. What the heck? I copied them all. Oh, I know what's going on. Okay. I only had 2 slides in there when I ran the program. It runs a list of all the slides that are there and says, those are the ones I'm going to run. So, okay, we can fix that. Stand by. There we go. Okay, now we share. Whoa.
Technical difficulties?
Yeah, no, they were all there. It was just the wrong folder.
Awesome.
Some days, maybe it's not worth getting up. Okay, everything is here. Quick test.
I have faith in you.
I have faith in my system. Oh, good. Okay, everything is coming up. Roses. Now I can share. Sorry about that.
No worries.
It was rehearsed. It really was.
It's the beauty of going live, man. Because
Okay, so here's kind of what I just described. So some user wants to access a web server, or he winds up contacting a load balancer. He doesn't know that it's a load balancer, and it directs him to one of the many web servers. This is how Google servers work. Now, the other kind, we did give a little bit of mention, but again, we didn't call it a cluster when we did this. And this is a DNS load balancer. So here's an example. It's the same thing. We're going to make these web servers. This guy calls up and says, I need the IP address of a web server. A DNS resolver goes out and round robins. He says, I know of 3 of them. So here's one at 11.0.0.1, sends that information to the client. And then the client doesn't go through a load balancer to get to the web server. He just contacts the web server directly. Next client calls the DNS resolver and he says, okay, well, I'm round robining. I'm going to give you the same duplicate process web server at 11.0.0.2. Hey, what's the default subnet mask for that? I'll take it in binary or in decimal. So he sends the information to the client, contact 11.002, and the client does, and so forth. So he can round robin that way. He's not a front end load balancer. He is a DNS server that says, you called me, you talked to this server. You called me, somebody else, you talked to that web server, and somebody else calls me. Here's the IP address of yet a different web server. All right, does that make sense? So that's two of the three types of clusters. We've got failover clusters, we've got load balancing clusters, and then we've got what we came to talk about today. Its technical name, High Performance Computing Cluster, HPCC. Sometimes they're just HPC clusters or HP clusters. And these are the ones that are in massive use today. And I'm just going to live on the three graphics and talk about them. I got 4 graphics here of that. So let's share this one.
Okay.
I will, I swear.
I believe you, Dave.
Your faith in me is what keeps me going. So we got this cluster, this high performance computing cluster. There's a couple flavors of them, but for our purposes, we're going to talk about this beast called a Beowulf cluster. And we'll get into what that actually means. All the pictures that I have up here are examples of Beowulf clusters. A Beowulf cluster says, I have a computer that's in charge of computing. It says, I know about a program that can process something really cool and powerful. Like how much, let's do how much dark matter is in there. You just give me the information. Except he's not going to do it mostly. He says, I'll tell you what we'll do. Let's get that program running on a bunch of different computers. And me, I will go have access to the data that needs to be processed. So I'm going to have the program installed in me. Each of these guys is going to have the program installed in them. And then I will take a little snippet of the program and or some data, and I will send it to one of these computers. And I do that with 2 programs. The one that we're concerned ourselves right now is the messaging program. He says, I will send a message to compute node number 1 and say, here's a task for you, start working on it, and when you're done, send it back to me. And he's got all kinds of tracking information on there. In the meantime, he takes a little different piece of data and a little different piece of code and says, you do it to this guy, and so forth and so forth and so on. And as each of these finishes their processing task, they send back the results to the scheduler guy, the main guy. He goes by a lot of different names. And then they send a message, okay, I'm bored. Whenever you're ready, send me something else. You got it. Pull some information, pull some code, and sends it back here. And he keeps working on that and working on that and working on that with these guys until he gets to a stop point in the program or completion or whatever the case may be. So this is an example of a high performance computing cluster, an HPC, we'll call it. So HPCs are made out of all kinds of different computer platforms. These are what they call pizza box servers. They can be used in general purposes. You could run an operating system on one of these. These are usually servers that can run multi-virtual machine operating systems. But see, the point here is like the other one, they're all going to be networked together, and there's one guy in charge of all of them. So these might have Xeon processors. They might have ARM processors. We find those in data centers, maybe proprietary stuff, maybe Intel or AMD CPUs, whatever. Oh my gosh. You could do this with Raspberry Pis. We'll make one of these guys into the scheduler, the head boss. make 1, 2, 3, however many more you want into compute nodes. We'll add them all together with a switch on a local area network. We'll run Ethernet cables and so forth. So that's what we're going to ultimately get around to end of today and next week. This is presently the world's largest high performance computing cluster made out of Raspberry Pis. You can see it's portable. I think it's actually on wheels. It has 1,060 Raspberry Pis in it. And there's a couple other non-Pi computers in there that are used. Well, one of them is used as, instead of booting from micro SD cards or flash drives or SSDs or whatever, they have a server in here, a traditional old-fashioned server with bootable operating systems on it. So when each Pi powers it up, it reaches out on the local area network in there, downloads and runs the operating system from that kind of server. And there's 1 or 2 more convenience servers like that. So freaking cool. Love the idea of HPCs.
Very cool.
Of the 500 fastest computer systems in the world right now, the best stats that I could find on them, 80% of them are running HPC clusters. So they're important stuff.
Very cool.
Now, that's our 3 types. Now we've got 2 categories: cows, clusters of workstation or cluster of workstations, and Beowulf clusters.
Okay.
Cow is usually what we find in a failover cluster or in a load balance. So cows typically don't have a bunch of servers, compute nodes working collaboratively on a single task. They work semi-independently, doing the same tasks as each other, sitting around just waiting in case one of them fails.
Gotcha. Okay.
And then we have, I'll say everything else in these notes that I want to do, things you might find them. Failover clusters, let me just read my notes here directly. High availability, high resiliency. So if a given node or cluster fails, a standby node or cluster can take over. So the systems, the standbys have to be run in sync with the primary systems. We mentioned that. Cows are found in mission critical systems like airline operations, something I know about, right? Dispatch, ticketing, things like that, and related. The FAA runs massive amounts of failover cows, and even then they have failures that take down systems for the better part of a day, sometimes a little more than a day. But what you don't ever see is the news where a system failed and the cow resiliency system picked right up and everything ran just fine. So there's major catastrophes where computers are made by humans, so I hear, and there's things that go beyond our control, but pretty cool stuff.
Very cool.
Thanks. And slide time. Then we got Beowulf clusters, which are obviously then collaborative systems. The examples that I showed up there earlier are all Beowulf. So the primary difference between Beowulf clusters and cows, at least the main difference, is Beowulf behaves like a single machine, whereas failovers and, load balancers, they operate semi-independently with management front ends. So Beowulf nodes can be thought of as a CPU and memory package that's part of a big monster computer. Beowulf. Hey, look up Beowulf sometime in images. You will find 50,000 images of Beowulf. This is one of the early block drawings. If you don't know who Beowulf is, I'll give you a little background on him, but there's another fun research project for you later. Okay. So why are they called Beowulf? Well, Beowulf is an old mythological monster, was defeated in Norse mythology by Grendel, the warrior. the traveling warrior who comes to kill the great Growler, comes to the village, finds them under siege by Beowulf, and he defeats them. And I tried to look a bit into why they called this technology Beowulf. There isn't a really cool thing that says, well, because this represents the monster and this represents Grendel. It's because they like the story of Beowulf. So the Beowulf concept was originally offered by a couple of NASA guys. What do you got? You've got the explanation.
You flipped it. You flipped it. Beowulf is a hero.
Beowulf beat Grendel.
Grendel was the monster.
Right. Sorry about that. Thanks.
Yep. Got to get that right.
Yeah.
Beowulf's the good guy. Well,
what
unless you're Grendel or Grendel's mom, then Beowulf is definitely the bad guy. It's all about perspective here.
Fair enough.
Yeah.
I was concerned we were going to go down the mythology road. So moving on. So we got a couple guys at NASA back in '94 who proffer this theory that computers could be created and operated like CPUs in a multi-CPU or multi-core server. They said all we need is a management system and a way to deliver content to those things. So we got these two Thomas guys, Sterling and Becker, in '94. Now I think that's the really magical thing. The first actual how-to didn't come out until '98. This was just a theory and an idea, and it took a long time, and they weren't the ones who came up with that first how-to. Somebody's advanced on their work. But what I love about this thing is if I talk about clusters, if I do a stand-up class and talk about clusters, if I do a dramas and mention clusters, if I mention cluster on a YouTube chat in Mike's AMA, somebody throws out the term Beowulf. I remember the first time that I mentioned a cluster when we started this a million years ago, probably the second or third show, maybe even one of the first or second. I said cluster, and Alice Potsy, who was not new to us at the time because she'd been on Mike's AMAs and participated there before, threw out the word Beowulf. Yes, Beowulf. So since 1994, that's 26 years ago, 27 years ago, it is the de facto clustering methodology. It has insinuated itself so into the technology that while there are a couple of other types, in that very short period of time, it has gone from inception to, yeah, that's the way we do it. There's almost no other way. And I love that. And what's really fascinating about it then is it's not a strictly defined configuration. It is a conceptual architecture. So there's no one way to do it. There's no right way to do it. There's a lot of different ways to do it, but they all have these roughly same architectural elements. They normally run in a Unix or Unix-like operating system. Again, that 80% plus. And there are Linux distros out there that are designed specifically to be optimal in a Beowulf cluster environment. Typically, they're built from free and open source software. So commonly, they use parallel processing libraries, including, here's the big two, excuse me, MPI, the message passing interface. This is what the controller, the scheduler, the primary, the head, whatever you want to call that guy, uses to communicate with the compute nodes and get their information back from him. And PVM, parallel virtual machine. That's the thing that actually makes the whole system appear to look and act like a single logical unit.
Okay.
There's different versions of MPI software out there. There's different products that are MPI. There's different products that are PVMs. Big popular one, runs on a lot of Unix, is MPI CH. Don't remember what the CH stands for, don't care. Controller, head, something, I don't know. All right, the machine that runs MPI and PVM has a whole bunch of different names. The controller, the Beowulf head, the scheduler. In earlier times, less politically correct times, there were masters and all the compute nodes were slaves. Now they're those names that I gave in the primary and all kinds of similar names to the compute nodes. Secondaries, they were called slaves historically. We're moving away from that term. So 98, a couple of guys named Radajewski and Edline, they came up with the first how-to. And of course, they did it back on popular Linux systems of the day. So it's a multi-computer architecture, can be used for parallel communications. It usually consists of a server node, and if it's mission critical, it'll have a failover node ready to take over if it cranks.
Mm-hmm.
And these can be run then on any compute nodes that are PCs running Unix-like operating systems. They use standard Ethernet adapters, standard switches. There's no custom hardware in most of these things. So let's just have a little fun with that term. There is standard hardware out there that's used in data centers that we would not find in small businesses or homes. They are standard, but from a certain perspective, because they are so unusual and so high end, like say, for instance, 400 gigabit per second fiber communications networks that are linking all of these things together. That's not custom, it's commercially available, but
Right.
We're talking about a $4,000 network interface card.
Yeah.
All right, so the server node, there's another name for the head. He's also the server node. He controls the whole clusters, serves the files to the client nodes. And he is the gateway to the outside world. It's what we use to start programs, stop programs, things like that. All right, I can slide past a whole bunch of this. I've covered it. Did that. Beowulf is okay. So Beowulf is not a special software package. Again, it's just a conceptual architecture. And that's really cool because that means it's available for a lot of different hardware and OS distros.
Cool.
While not absolutely necessary, it is generally appropriate that all of the compute nodes are very, very similar, if not identical. So same make, model of processor and amount of RAM and things like that. But you can have some variation in there.
Okay. But better if they're uniform.
Yeah, it makes sense.
It does, sure.
Now, one of the things that we could also turn into clusters, I didn't mention this, is just kind of cool in passing. You may be aware of people or projects where they take high performance video cards and use them to perform non-video computations. It became somebody back in the 90s or maybe early thousands took one of the popular video cards of the day and reprogrammed it. Instead of sending it video drivers and things like that, they reprogrammed the cores within it, the CUDA cores and the things like that, to do password hacking. They still do that. And they were so much faster than the general purpose CPUs of the day at that task. So whereas the best CPU of the day back then might hack whatever password they were trying to hack over the course of 3 months, video cards could do it in 2 weeks or less. And they continue to do that as video cards get better and better and better. They're more powerful. They are very math oriented. And so these things are used in both single and in parallel computing platforms. In fact, all the big name video card manufacturers that you know of, NVIDIA and Radeon, and there's a couple other lesser knowns, they make video cards that only have one video output and it's just basic raw in a VGA or maybe simple HDMI, but they live just to be programmed as a processor. And so we can make Beowulf clusters out of these things too. It's kind of magic. And when you get down to it, crypto miners that are doing crypto miners with chains of video cards, those are Beowulf clusters.
Right. That's the Bitcoin and Ethereum and all that stuff, right?
Exactly.
Or what was the one that went viral yesterday? Dogecoin, something like that.
I missed it.
It was a one-word tweet from our Mr. Tesla,
Okay, Musk.
and it like basically doubled the stock price.
Yeah, I heard a couple days ago that he bought a bunch of some kind of ethereal coin and sang its praises, and it exploded. I didn't know it was yesterday, but okay. Okay, so we've been using the term cluster here. It's a correct term just for the sake of fun. It is traditional since the first attempt at creating clusters with Raspberry Pis to call those clusters a bramble, right? Because brambles are bramble bushes or brambles of Raspberry Pi bushes. So we'll use that term interchangeably. If we're talking about bramble, we're talking about Raspberry Pi distros. It's 1/4 here. I'm halfway through these notes. I'm going to speed it up a little bit because I want to have about 15 minutes of leftover. If I don't, I'm not going to run long, but if I run short and there's something important here, I will complete the discussion next week, because the actual exercise, as always, is not particularly complicated. Time consuming, basically because you've got to make a whole bunch of micro SD cards, and that manufacturing, that cloning is time consuming. Okay. So let's mention Raspberry Pis as an actual tool.
Okay.
Can I make an effective Raspberry Pi Beowulf cluster that's, again, effective is not the best word. I'm clipping a little bit. Sorry about that. I'm making an adjustment there. Well, okay, let's do an example here. Blender. Blender is a web app. Okay, it's used.
What is Blender? What is Blender?
Blender is a web app that is used for people to create three-dimensional videos. You can, like create machinery. You can create illustrations out of the things. You can make people walking. There's all kinds of really cool things you can do with that. And the creation process is not difficult to learn. Like anything, there's a learning curve. Mike is pretty good with Blender, as a matter of fact.
Right.
And it's really funny because he'll play with something with Blender for a while. His skill set comes back to him in short order. He makes something and then he doesn't play with it again for a year. And then when he goes and picks it up and plays with it again for a year, he's got to run through that learning curve again, though it's a lot quicker than the first time. Right. But then when he gets cranking, he makes some really, really amazing stuff. Well, it's not the creation that sucks up all the CPU horsepower in this web app. The web app uses horsepower from the hosting site, and it uses horsepower from your client. When you're done creating it, now you have to save it as a video, an MP4, an MP3, whatever the case may, not MP3, an AVI, whatever the case may be. That process is called rendering, and that uses most of the horsepower on your local machine, and it uses a lot of power. So you can set up multiple computers, each running a Blender session, and with a little bit of magic and configuration, get them to be a Beowulf cluster. That's native functionality that's actually built into Blender. The tutorials out there that I've looked at suck. Just trying to make it work, and then you got to configure this, and they're just not well explained. They're not written by people who obviously are devoting their life to instruction. This is what I did, and they miss critical steps and things like that. And I just haven't found a good enough one, but it doesn't matter. But let's say we take one computer of a given high-powered system, and we render something that takes an hour.
Okay.
A 4-machine system will take around a half an hour or a little less. It's not, you get this many times the performance. Now take one good high-powered best machine of the day today and render it using whatever, an hour's worth of time. To do that same amount of time and rendering with Raspberry Pis will take 6 to 8 Pis. Because again, these are, 1.8 gigahertz. And when you're doing this, they tend not to be multi-core. So, they're not an efficient tool to make a really powerful collaborative computing system, but they are great to learn. The message protocol system, the PVM system, all of that works exactly the same if you're working on supercomputers or if you're working on Pis.
Very cool. So this since you mentioned massive power and all this stuff, one of the questions that came up while you were talking about clustering was about powering the Pis in the cluster. It especially came up when we saw the 1060 Pi thing. It's like, okay, how do we deal with power in that case?
Funny you should ask that.
Funny I should ask. And in fact, I think it was Kevin Lopez who asked, but yeah. Lay it on us, Dave.
So this is 1, 2, 3, 4, 5, 6. This is a 6 Pi Bramble. And what you can do with this is power it in one of several ways. Okay. Method number 1 would be a power strip with an individual wall wart and a USB power going to each of the power things. A big power strip, and use sideways wall warts. That works. It's okay.
It works, sure. Sounds kind of wiry.
Yeah. For a small Bramble, this is a high-powered phone charger from Anker. Happens to have 6 outputs on there with 2.4 amps out a piece. This is an 80 some odd watt system, and this won't use full power. And if you don't turn them all on at the same time, you turn them on one at a time until they're fully booted. When they're all booted, they're only running around 50, 60 watts. So that works great.
Okay. Kind of like the way we used to have to do with laser printers, right? Turn on the laser printer first, then power up your computer.
Right.
Power up one system at a time. Because power up, in case you guys weren't aware of that, power up is like when the computer is going to demand the most initial, just like startup. And then it calms down into running mode and draws way less electricity. So,
right. The third method, you can buy these modular power supplies. They're very inexpensive. There are 5-volt models, there's 12-volt models, there's 48-volt models, whatever. A 5-volt model that's good with 80 amps, you figure 2.5 amps per price, is going to run you around $60. It's not very expensive.
Right, not for what
and they've got a plus output and a minus output. And what you do is you create a string of, you can buy these for about $1.50 a piece. This is a micro USB connector that's got bare wires on the end, one red, one black. There's no data wires in here. There's just power wires. So you can parallel up a bunch of these together. I'll do a how-to on that someday. And then just hook all the pluses to the plus terminal, all the minuses to the minus terminal, and plug these in. You can even go really nuts. You can cut these wires off, put jumper ports on them, and there's a couple GPIO pins that you can run power in instead of the USB micro connector. There is a danger in that. The USB micro power connector has circuit protection. It's got short and a limited amount of over voltage protection. If you use the power feeds on the GPIO pins, there is no such protection. So real easy to fry a pie with a surge or a short.
And we all know that baked pie is far better than fried pie. Sorry, couldn't resist that one.
I don't know. All those Hostess fruit pies are fried.
I wouldn't call those pies, but yeah, okay.
Okay, so we're going to need an operating system on each of the nodes. They're all the same. We're going to need a messaging system. We're going to need a piece of program that allows them to participate in the virtual machinization. And then we need, basically the last thing, a program. So not every program, however, most of them can be collaboratized. There's a word of the week.
Wow.
But we'll dive into that. All right, so our purposes, we're going to work with a traditional Beowulf with primaries and secondaries, running common message and scheduling. Hey, good, we're kicking off here. We're getting close to the end. By the way, program may or may not support. So some programs, while they may not even been designed to run in a parallel environment, will work because they're so simple. Complex programs tend to, if they can operate on a multi-core system, if they're multi-threaded, they will usually work in a Beowulf. But big, powerful programs that are designed to go single core probably won't. So
Okay.
what do I need? Hardware-wise, I need a computer and a power supply and a network. So I'll need a switch and Ethernet cables. I'll need an operating system. We'll be able to do it on Raspberry Pi OS. There's a lot of other Linux systems we could use. We'll need the program that we want to run collaboratively. And then here's the fun part. They have to be customized. That customization comes in a couple different flavors. First of all, every computer in the cluster has to have a unique name. And not surprisingly, they all have to have a unique IP address. That makes sense. Now, we got to boot this thing up. So how do we do that? Well, there's 4 methods when you get down to it. One we're going to do in a project down the road in a few months, and that's Pixie booting. An image of the operating system, of an installed operating system, is pulled over the network into RAM in your Raspberry Pi and your whatever computer, and so it's getting its operating system files instead of from a mass storage device that's directly connected to your computer. It's getting it as an image file off of a file on some, they call it a Pixie server, a pre-boot execution environment server. So that's one way, get it remotely. And that's the best way to do it if you're talking about massive numbers of nodes. Otherwise, we're going to do it the old traditional way. You could, if you choose, use a micro SD card. You could use any of the common external connectable peripherals that you can connect either with GPIO pins or with USB. So you could use an external spinny drive, an external SSD. You could use a flash drive. Any of those are acceptable. We're going to go the simple way for our experimenting. We'll use a micro SD. But we went through a lab a couple of weeks ago, I don't know, 4 or 5 weeks ago, where we talked about how to boot your Pi from a flash drive. That same process is used for an SSD plugged into the USB port or a spinning drive. Downsides of those external drives, they do draw a little more power. You're going to probably need, they're not going to be able to get power directly from the Pi. Possible exception is SSD or flash, but certainly no spinning. Okay, so we start in the beginning. You pick a Pi, doesn't matter, and you do a fresh, shiny, brand spanking new installation of Raspberry Pi OS. And then you're going to do a configuration on it. You're going to, first of all, give it a static IP address that's going to be unique. You're going to give it a name. You're going to install the messaging protocol. You're going to install the PVM. Yeah. And you're going to install the program that you want to be run in parallel.
Okay.
Done. That's a template.
Okay.
Now,
So
for every node, including the head that you're going to have in your cluster, clone that template.
Okay.
And then tuck it away because he's going to be used for expansion and scaling later up.
Okay.
All right. Take that first one and set up your primary, your head, your scheduler. And there's nothing that you should need to do that. You've already given it the head's name. You've already given it a static IP address. If you want to change them, now's the time to do it. And we have to have done one other thing before this, and that, of course, is make a plan. And the plan includes these 2 critical pieces of information.
Okay.
How many compute nodes are you going to have? I'm going to backtrack on that in a second.
42, obviously.
Obviously. And what is their static IP address going to be? So you'll need that list.
Okay.
Because the way the Bramble that we're going to create works, he has to know, of course, all of his secondary nodes. And the configuration file that he uses, this is so cool, is the hosts file.
Good Lord, really?
Really does. So all we've got to do, and I'm going to shake you into this and show you this, is edit the hosts file and put in the IP address and the names of all of the secondary hosts that you're going to have. So let's talk a little bit about the host file for just a second. How am I doing here? 29. I can do this.
You've got about 4 or 5 questions kind of stacked up.
All right, let me do this host, then we'll do questions and we'll come back.
Okay, sounds good.
Oops, I got to run this. DNC, we'll use this guy. I used him yesterday. Now, everybody remember what the hosts file is? It's a text file that has a list of IP addresses and names that you want to create to refer to those IP addresses. So for instance, Scott's got a machine on my LAN. In a second, I can't talk and type this code word at the same time. So he's on my network. He's got a computer. He's got an IP address. And I want to ping him. I want to send email messages to him or some other kind of message system. Well, if I know his IP address, that's cool. But better if I know his IP address and a name that, or multiple names that I want to call him. And what I do is I go into my computer's hosts file. It's a text file. And I put at the beginning of a line, Scott's IP address, and then one space or more, a name that I want to refer to him when I'm on my computer, Scott. And maybe I put a second name after that, do another space, boss, and another name, author. I can do as many of these as I want, up to 170 characters in the line, 255 characters in the line. Okay, let me share this. That part's done. And this file exists in Windows. This file exists in all Linux systems.
And Mac OS.
Rumor has it Mac OS. There's something about them using SMB or Samba. I'm not sure. Oh, why is he not here when I want to troll?
Right.
All right, so I'm going to go over here to the Etsy folder. And here's my file called hosts. So I'm going to take a look at the contents of it. I've never changed this. This is an original host file in here. Cat means show me the contents. And there's 4 entries in this file, 5. So let's actually just go and edit the thing. Sudo nano hosts. Sudo has only one S in it for some weird reason. So Scott's on my LAN. I can do a line here that says Scott's IP address, 192.168.1.177, 1 or more spaces. Scott, boss, author, God.
Love it.
So we will do an entry on our head server with the IP address and the name of each of the compute nodes that we're going to do. Simple enough. Sweet. Now I'm done with the scheduler machine. Now I'm going to take that template and I'm going to clone it for each of my Raspberry Pis. And once I made a clone, I'll start it cloning again. I'm going to show you some different tools to do cloning next week. But you can use Balana Etcher, or you could use the native Linux utility DD, or you could use the new, I don't remember its official name, the Raspberry Pi image writing program. I think you can use that to do etching, not 1,000% sure. I use Etcher, that makes more sense for me.
Okay, sounds good.
Okay, so I've cloned one. I'm going to plug that into a Raspberry Pi and boot it up. It's going to boot right up. It's all updated. Oh yeah, obviously after you do that install, make sure you do updates and upgrades and make sure it's current. And now all I have to do to customize that machine is give it its unique IP address and its unique name. I don't have to do anything in the host file or anything like that. So here's an important step. Put a label, tape or whatever, on each of your compute nodes with the IP address and the name, because there are times when you're going to want to service one and you want to know which one you're servicing or unplugging or whatever. Hey, that's it. That's all
Wow.
there is to the creation of the Bramble. Make a template boot drive, set it up so that it'll work on the head, and then clone each one of those and customize a static IP and a static name for each of the secondaries, and obviously get them all hooked up on a local network on a switch and power them all up. But folks, it doesn't get any simpler than
Very
that.
cool. And so next Friday, we'll actually go through the time-lapse version of showing all of those different pieces, and then with examples and all of that, right?
Exactly right.
Okay, very cool.
I did that. I think I've actually through everything here. Oh yeah, okay. So 2 things for when you're done and you've used them to run a program. 1, things change over time. The operating systems need to be updated. The program that you're paralleling needs to be updated, upgraded, things like that. Systems crash. Well, if we're talking about a 3-node cluster, that's no big deal. I'll SSH into the head and I'll run sudo apt update ampersand sudo apt upgrade, and he does his thing. And at the same time, I can SSH to another one of the secondaries and another secondary and do all those independently. No big deal. I do that here. I have on my desk 5 Pis. Yeah. 3, 4, 5. In the living room, there's a pile of them up in the upstairs studio and lab. But for these 5, every Tuesday morning, I log into each one with SSH and I start the update upgrade. And then I just let that run. And at the same time, I can start another one, and I get them all started in about 5 or 6 minutes. And if there's no big changes, no operating system updates or something like that, they're all done in about 10, 12 minutes, something like that. And then I go break the SSH connection with each of them. But what if I had 30 or 40 or 100 or 90? That would be a nightmare. Yeah. So there's 2 possible fixes. If I always do the same thing, if all I ever do is update and upgrade, I can make that a cron job. We haven't talked about cron jobs in here, but it's a task scheduler kind of thing built into Linux. So that's a cool way to go. But that doesn't help me if I have to do something new or different. I'm going to change out the program. I'm done with running the old parallel program that figures out dark matter, and now we're going to figure out how long it takes a photon to get from the center of the sun to the corona, and we're going to track it. That's a huge thing. It takes about 100,000 years, believe it or not. So now I got to get a whole new program installed in each of these things. Well, maybe I could write a script, SSH into it, and launch the script. But they make utilities out there with one program. It will call out to all of the SSH servers that you specify and run the same programs on them simultaneously. You'll find those if you do a Google search on them under, wow, massive typo here. There, fixed. Nope. If you search for multi-host SSH tool, and the 2 big ones out there is one called parallel-SSH. It's on w7cloud.com, and the other one is ht_SSH. That's at a place called hypertable.com. So a little bit of configuration, a little bit of a learning curve, but with this, I set up one time, it calls up all my Pis, does the same thing to all of them, whatever I create a script for, or even I'm typing it here on my hypertable utility, it's happening simultaneously on all those Pis. Darn cool.
Very cool.
Scalability. I'm done. I'm not satisfied, perhaps. I'm done with my project. I need more Pis. I need more secondaries in my cluster. So it's really easy to scale a Beowulf cluster. Get another computer, same type. Clone your template. Boot it up. Make the 2 mods. Change the name. Change the IP address. You've added and then update the hosts file in the scheduler machine. You've scaled up. You've added another node.
Cool.
And that
Okay.
is magic.
Absolutely.
And the final thought that I have on this is a 2-node cluster. Maybe I said this and maybe I already lost track of my train of thought, but a 2-node cluster might or might not work with value. Problem is this: if you use a VPN, a PVM machine that can participate in the processing of the program that you're paralleling, a 2-node cluster is cool. Because then you've got 2 computers. I'll schedule myself sometime, and I'll schedule this secondary node sometime. So now you will improve performance over a single non-clustered machine. However, most scheduler machines don't do actual processing. Their job is to manage the secondaries. So if you make a cluster with 1 secondary, that's going to be slower than having a single non-clustered setup, because not only is he busy doing the job, he's also doing all the interaction with the primary. So from a practical standpoint, if you're going to build a cluster, 3 is a minimum. From a non-practical but learning standpoint, absolutely fine to make a 2-node cluster.
Okay, sounds good.
Okay, I got the 9 steps. It's 41. Just going to read them to you. I basically covered them. So step number 1, plan it. Which is going to be your primary, which will be the secondaries. Plan your names, plan your static IP addresses, plan your hardware, have an appropriate set of cases. Doesn't have to be a tower case. You can do them all in individual cases, but you're going to need some real estate to put these all down in, or stack them, or whatever. Plan your power supply. It's all planning. Plan your network. Do you have a switch that's got enough ports to do your Bramble? Here's an 8-port switch. That's great for a 6 or 7 node Bramble, because I want one of my ports to be able to hook up my computer so I can talk to it, and I want another port to go to the internet for updates and upgrades and things like that.
Right.
All right, we'll call all that the physical plant. Plan and set up your boot media. So are you going to use micro SD cards? Are you going to use SSDs, mini drives, Pixie servers, whatever? Plan for growth. When you pick, if you're going micro SD card, get the best one you can get, biggest, and the one that supports the most writing. Okay, I don't want my Bramble to fail because I bought a cheap micro SD card and it started wiping out memory cells, storage cells in the micro SD card because it has a low rewrite or write capability. So get the pro versions, get the extreme versions. Real world, I wouldn't start with less than a 32 gig card, probably bigger. For here, 16 will probably work for a simple experiment. But if you're planning on having some fun with this later, you don't want to redo all that in a bigger card. Start with what you need. Start with 32 or up.
Okay.
Okay, step 2, gather up all your hardware and set up your physical plant. Don't power up any pies until you're ready. And when you do it, we're going to do it one at a time, so the configuration is easy, so you know which one you're connecting to and changing, because you're going to start out.
Dave just froze up on me. Did he freeze up on you guys too? He's got a great pose right there. Frozen. Okay. Ah, yes, I zapped Dave right there and said, that's where he needs to stop. But he's going through the 9 steps. Hopefully he'll pop back on here in a moment. And yeah. Hey, Dave. So a couple of questions that came up while Dave is frozen. Way back at 240, Kevin Lopez asked whether we've tried Windows 10 on the Pi, and a lot of the comments that came up were, or in response to that question, were basically why, and some subsequent discussion. Kevin responded that he wanted to experiment with working with Windows Server with a bunch of Pi clients, and the question is setting up Windows Server on a Pi. There's certainly a Windows version that's built for ARM processors, but it's not Windows Server, I don't think. Dave would have to, I was waiting for Dave to respond to that question. But setting up Windows Server on a regular server machine, especially with the 9-month evaluation copy you can get from Microsoft now, is a good way of taking even a fairly marginal machine, because running headless, Windows Server doesn't take a phenomenal amount of memory, especially if you're not making it work for a living. You're playing and experimenting and stuff. You can get by with 16 gigabytes of RAM pretty easily with Windows Server. Not in a production machine, but in a experimental machine. And so using that as a separate machine and then connecting all the Pi nodes, I think, Sean, would make more sense than trying to put Windows on a Pi. The Pi, as Alex and several other people mentioned, is a little underpowered for running Windows. Dave might still be talking. Yes, that is correct. And then Tulowit had some questions way back at 2:45. I'm going to go back up, and we can do this, assuming I can go all the way back to 2:45, which I might not be able to. Hold on, hanging, waiting. Oh, I'm already gone. 2:45, 2:40. I swear I wrote it down. Maybe it was 2:54. Hold on. Hey, it was 2:54, not 2:45. How about that? Tulowit asked the concept of cold redundancy, warm redundancy, and hot redundancy when talking about failover with clusters. And Tulowit, you can certainly, pop back to the live chat here, and you can certainly add to that question. When we're talking about the warm redundancy and cold redundancy, I think when you're looking at scheduling with a cluster and talking about how the controller actually decides when to go to the next machine, it's usually the machine that is the last one. How do I say this? The guy who's worked the least is who goes next. Right, so that might be the cold redundancy, or in this case, the when you're doing load balancing, you would want to go to machine number 3, then machine number 2, then machine number 1, and then reverse again. And Dave is coming back up, and that's always fun. Hey, Dave, welcome back.
Long time no see. I have no idea what glitched or why that glitched, but I do have a theory. I think it's because my switch has nothing plugged into it.
It's okay. I answered at 1.5 of the 3 outstanding questions that were out there.
Sweet.
There's one left over from Tulowit before you get back into your 9, okay. The 9 steps. Since I was in the middle of the explanation, it was about failover and hot, warm, and cold redundancy.
Ooh. So that's a sec plus kind of issue. That's a hot site, warm site, cold site thing.
Well, yes, it's not the site though, but the redundancy in the cluster itself.
Okay, so we kind of mentioned that. It would depend on a whole bunch of different variables. So in the kind of Beowulf cluster that we're doing here, man, cold, warm, and hot. They don't hold data. So they are natively cold in a Beowulf, not in an HA, not in a high availability or failover mode. So Beowulf, the head sends out a snippet of code and data and says, process this. I'm tracking what you're supposed to be doing and I'm waiting for the response. If the response never comes back, he'll try and contact the guy. If he doesn't get that, then that would trigger a failover, and the failover can be cold. He doesn't have to know what the old one was doing. He just says, I'm waiting for the snippet from the head, from the scheduler. Some high availability systems would need, if they're not mission critical or mission critical, an appropriate cold, warm, or hot setup. And I can't claim enough background or study time or expertise at this moment to offer a really good answer than other than circumstances will dictate if it could, should, would be hot, warm, or cold.
And we can always take it up on Discord after, to that way Telewick can actually give us in real time a little more explanation about what he's asking about. There was
Sounds
one
good.
more question that is outstanding,
Okay.
and this it is as pointed out 12 hours later in India than it is here,
Okay.
and so our man Anmol Chandra is up.
What's our time, Mark?
This is 3:25 p.m.
Okay.
our time.
Sir, I wanted to make IRC server for very less cost, so I thought I would go for Raspberry Pi Zero wireless, but I have a question. Can I also use an Arduino for it? No. You need a computer. An Arduino is a microcontroller. It doesn't have an operating system. It doesn't have enough memory to run an IRC server. So no, you want to be looking at a Pi. Pi Zero might be able to do it. I actually have a project on my list of potential upcomers. Let me look at that list and see what date I'm thinking about. It'll swing a little bit, but let's go up one here. Overclocking, install VPN, install a chat server. My tentative plan is to do that on the 26th of this month. So 1, 2, 3 weeks from now is my tentative plan. That may push 1 or 2 weeks, but if you can wait that long, we'll do something.
And Anmol, you can always email Dave directly, right? And just to confirm what day that he's going to do that, because I know it is a challenge because you're up into the wee hours of the morning for you to be able to catch this live. So if he's going to do it in 3 weeks, buzz him 2.5 weeks from now and just say, are you going to do it this Friday? So you can know to take a nap.
Right. And if you participate on our Discord server, I do announcements like that. This week we're going to do, so you can always look that up. You can ask me direct questions on the Discord server. If you just post it and I'm not online, send it to me as a direct mail. I'll see it and I'll get you a response, and I will certainly respond to you on email, traditional email. My address, daveR@totalsim.com.
Okay, cool. All right. So I interrupted you. You were on step.
It's all good. We're almost done.
The spirits of the internet interrupted you.
That was
in the middle
weird.
of step number 2. So
okay, so we completed step 2. Gather your hardware, set up your physical plant, get everything wired up, no power. Number 3, install your micro SD card into your primary. Customize it with an IP, a static, and the hosts file.
Okay.
Step 4, clone the template for your primary and for each secondary. Customize your secondary. Note, set up the template, setting up the template and cloning of the template for each node is time consuming. So setting up that initial template, look, if you do an install of Raspberry Pi operating system, as it goes through its thing and it does updates and upgrades, it's about 2 hours from the time you create the initial image and you boot from it and you do the initial configuration and then update, upgrade, 1.5 hours, 2 hours. And then the cloning of each one, depending on the size of the micro SD card, a 32 gig SD card takes about an hour to clone.
Okay.
So that's where all the time is. Number 5, set up the rest of the hardware. Each Raspberry Pi needs a network connection. Wireless will work. I like mine as a married set to a dedicated local area network. It keeps all that traffic off my Wi-Fi network and the rest of my household wired network.
Okay.
Like everything. But I can't afford to go out and get another switch. Okay, do it wirelessly. There's not a lot of traffic going on between the two of them. Make sure when you case them up, these are going to be busy machines. They're going to be high load CPU. So do them in cases that have good ventilation and or cooling solution, especially the head.
Okay.
Don't power your Pi until each one is ready. Now you could use the master template and avoid DHCP as long as you set up your primary, do everything you have to do to it, and then unplug it from the network or power it off. And now do a secondary, power it up, do your business on it, power it down, and do that for each of your secondaries. Now they'll all have unique IP addresses, and you can power them all up one at a time. They only take about a minute or less to boot up.
Okay, sounds good.
So that's actually step 6. Starting with the primary, insert a clone of the template, assign the unique static IP, assign the unique name, update the host files, and of course, make sure everything is labeled. 7, one at a time, install the clone templates, uniquify them. 8, once they're all running and customized, the Bramble is constructed and ready to operate. All we've got to do is trip the program, get it launched, get it running on the primary. We may or may not have to provide data from someplace. Maybe we can put it on there. Depends on what kind of program we'll use. And I haven't picked one. So that's why I haven't mentioned it yet. Semenbold. Nice grammar. And finally, step 9. Oh, that's interesting. Launch it. Make it happen. I talked about scaling up. Let me put up on share now. 5 minutes ago. This is perfect. I'm at the end of my notes. I'm going to show you the primary tutorial that I'm going to use for us to do our task with next week.
All right.
So go get yourself a heads up on this. Do a little reading. And you can do a little bit of baking in the oven before we do too. So it's at raspberrypitips.com. Whack raspberry-pi-cluster. He actually has a couple different documents that he's used to talk about this. This is the main one, the step-by-step. There is a pre-document on there. Just look around his site and do research on Pi cluster at raspberrypitips.com, and you'll find out most everything that I'm going to do. So that's it. If there's no other major questions, I just put up the contact, so I don't need to repeat that. Let me bring the Discord server info up again and our discount again, and that'll close things off.
If you have a minute or two, Anmal has a couple of questions that came in late as well.
Okay. Real quick then, 20% off A+, Net+, and Sec+ Passport ebooks over at TotalSem.com. Use the checkout code Groundhog2021. That's good through Sunday. Here's our unofficial Total Seminars Discord channel. Scott and I will be there shortly after we finish up this AMA. So come on over. I lost the name. It's covered up by 40 windows that I have open, but I'm sorry, I lost your name.
Anmal.
Anmal. Okay, thank you. So discord.gg, lowercase t, uppercase C, all lower, JAAN, capital P, lower X. And we will be on there. You can talk to us real time. And I may even fire up the camera. And is that okay? And we did that, the cluster tutorial. Okay, so that's everything.
Yeah, Sean, I don't see a 4-digit code. You can also contact Tulowit, who's I think a moderator for the Discord. So if there's some other code that you need to get on, I'm not aware of it.
Okay, what else you got from Anmal? Give me time, Mark.
Okay. 355.
355, zooming way down.
Yeah, all the way at the end.
Okay. Okay, thanks. I have a project ID with Raspberry Pi. You can run a TCP dump in local Wi-Fi in the office. Absolutely, you can. In fact, if you go back a couple of weeks, you'll see that we installed a Kali server on Raspberry Pi. That's got built-in TCP dump. You can do TCP dump as a standalone product on Raspberry Pi OS. Certainly, it works fine. You can run Wireshark. Personally, I'm not into TCP dump. It's a little too textual for me. I like Wireshark. They do it all the same. And contrary to some people's assertions, neither misses any packets. The NIC and the program are absolutely fine. So there's no dropped or missing frames if you set up to capture anything. So if you prefer the textual world, knock yourself out, do TCP dump. I like a graphical world when I can get away with it and it does everything I need to do. And Wireshark certainly fits that mold. Okay, so let's do TCP in local office and process the MAC addresses and wish everyone good morning in the office. Okay, so that's two things that you're looking to do. You're going to need a messenger. You're going to need a map from the MAC addresses to the computer name. You get that from ARP and RARP. It's a good project, but it's not a single standalone. A TCP dump can send a message to a MAC address, but the operating system on that system, on the host system, has to be able to receive the message. And there are some native ones that are built into Linux, including Raspberry Pi OS. So it's doable. It's nothing that I can explain in -9 seconds ago. But catch us on Discord. Come back here on Friday. I'll save that as a research question. We'll talk a little bit about it.
All right, 3 seconds. 3 seconds. Nigel broke the pins on his card slot on his Pi 4. Is that fixable, or does he just buy a new one?
No, I mean, you got to be good with a surface mount rework station. When you say the slot pins, and the only slots I can think of are way too small for anybody to work with, and to certainly work with a regular solder iron.
Buy a new one, Nigel.
Yeah, $35.
So at this point, it is 4 o'clock.
It is. We've got to say goodbye.
We do.
Everybody have a good and safe weekend. We'll see you on Discord in the next few minutes. Scott, thank you as always. A wonderful job.
Dave, thank you. That was great.
Okay, everybody, we'll see you next week. We'll do more clusters. Mike is doing his regular AMA on Monday, 2 o'clock Central Time. So until next week, good night. Bye. Thank you, Michael.
And now we stare into the camera.
I love staring into the camera.
I know. I love the camera. That